Hello, in this section we're going to focus on analyzing graphs of functions. In other words, learning how to read information directly from a graph. Let's get started. Here's what we're going to cover. We'll learn how to use the vertical line test, find zeros of functions, identify where functions are increasing or decreasing, find relative maximum and minimum values, calculate average rate of change, and recognize even and odd functions. Let's start with the graph of a function. A graph is made up of ordered pairs, x and f of x. X tells us how far left or right we move. F of x tells us how far up or down we move. So the graph shows how the output changes as input changes. And remember, because it's a function, each input corresponds to exactly one output. Now let's talk about the vertical line test. This is how we check if a graph represents a function. Imagine drawing vertical lines across the graph. If any vertical line touches the graph more than once, it is not a function. If every vertical line touches it at most once, it is a function. So we're asking, does any x value have more than one y value? Now let's find the zeros of a function. Zeros are values of x where f of x is equal to 0. These are the points where the graph crosses the x-axis. In this example, we set the function equal to 0 and solve. First, we factor. X squared minus 5x plus 4 is equal to x minus 1 times x minus 4. So the zeros are x is equal to 1 and x is equal to 4. And you can see those exact points on the graph where it crosses the x-axis. Now let's talk about how a function behaves. A function is increasing when, as x increases, f of x also increases. A function is decreasing when, as x increases, f of x decreases. A function is constant when the output stays the same. Visually, increasing means we're going uphill. Decreasing, we're going downhill. And constant is a flat line. Now let's look at the relative maximum and minimum values. These occur at points where the function changes direction. A relative maximum is a peak, and a relative minimum is a valley. These are also called local maxima and minima. Important, they are not necessarily the highest or lowest overall, just within a certain interval. Now let's talk about average rate of change. This measures how the function changes between 2 points. We calculate it using f of x2 minus f of x1 divided by x2 minus x1. This is the slope of the line connecting the 2 points. That line is called a secant line. Now let's apply this formula. We're given f of x is equal to x cubed minus 3x on the interval -2, -1. We plug into the formula f of -1 minus f of -2 divided by -1 minus -2. Now evaluate. F of -1 is equal to -1 cubed minus 3 times -1, which is equal to -1 plus 3, which is equal to 2. And f of -2 is equal to -2 cubed minus 3 times -2, which is equal to -8 plus 6, which is equal to -2. Now substitute, we get 2 minus -2 is equal to 4 divided by -1 minus -2 is equal to 1. 4 over 1 is equal to 4. So the average rate of change is 4. That means the slope of the secant line is 4. Finally, let's talk about even and odd functions. An even function is symmetric about the y-axis. F of -x is equal to f of x. And an odd function is symmetric about the origin. F of -x is equal to negative f of x. For example, we are given g of x is equal to x cubed minus x. Now test. g of negative x is equal to negative x cubed minus negative x, which is equal to negative x cubed plus x. We factor out the negative. That means we get negative, open parentheses, x cubed minus x. So g of negative x is equal to negative g of x. Therefore, this is an odd function. To wrap things up, we've learned how to analyze graphs by checking if they represent functions, finding zeros, identifying increasing and decreasing behavior, locating relative maxima and minima, calculating average rate of change, and recognizing symmetry through even and odd functions.